Hi, my name is George. I'm the president of Easytork. In today's video, I'd like to discuss a couple things. The first is I want to discuss how to automate using our actuator to a rotary control valve. In this case, we have a fairly common segmented valve with a spline shaft. The second part of the video, I'd like to discuss our performance metrics of using the Easytork actuator over a spring and diaphragm rotary actuator. And in the last section of the video, I want to talk about how to convert our actuator from a double acting to failing counterclockwise or failing clockwise. Okay, so let's talk about actually assembling our actuator onto the segmented valve. First things first, I already installed a bracket onto our actuator, just out of simplicity for the sake of the video. It's as easy as this. You'll notice the spline will go directly through and through the actuator. It's completely absorbed by the actuator itself. Now the valve is currently, the ball in the valve is currently set in a closed position, which matches the orientation that we have on our yellow indicator. So with that being said, I can turn this actuator 180 degrees and mount it either this orientation or in this orientation. Now keep in mind that this valve is a 2-inch segmented valve, and this actuator weighs about 13 pounds or about 6 kilograms. This actuator would have enough torque for either a 3-inch and possibly a 4-inch segmented valve for either double acting or fail-safe. In the second part of the video, I want to talk about the control valve performance of using an Easytork actuator over a spring and diaphragm rotary actuator. I'm going to finish the assembly by putting this positioner on top of our actuator. Note that it's a Namor mounted positioner that will be accepted by our Namor mount on top of the actuator. Any Namor mount positioner will work. Okay. So when we took a package like this and did a control valve diagnostic test, we took one to a benchmark type of machine. Our HDRL, which is the hysteresis, deadband, repeatability, and linearity, exceeded or was equal to a spring and diaphragm actuator. The HDRL measured from the positioner all the way to the valve stem itself. Now, the reason why our actuator performed at such a high level for control valves is because our design is very simple. If you think about what spring and diaphragm rotary actuators do, they convert a linear motion into a rotary motion. Whereas for us, this is the cutaway of the same actuator that's currently installed on top of the control valve. We have a pure rotary to rotary moving actuator. So we're not converting a linear motion into a rotary motion. And second, the connection between the control valve and our actuator is very pure. The valve is completely absorbed by our actuator without a need for an intermediary coupling. And you can see that there's no motion transfer loss. It just moves like that. So what we have here is a pure rotary to rotary motion with a pure connection for a rotary control valve. The other design difference that we are able to offer is instead of using springs as the fail-safe mechanism, we have an onboard air reservoir that would drive the actuator to either fail in counterclockwise or fail in clockwise motion with the loss of electricity and or air supply. There are a lot of different control valve manufacturers that make their control valve shafts in different shapes. For example, the spline is one of the highest performing shapes for control valves, but we can also direct mount our actuator to a double D, a square, or a bore and key. For example, this is a double D shaft that we can install directly into the actuator and still get the high level of control valve performance. In the last part of the video, we're going to talk about how to change the function of the actuator from a double acting to fail in counterclockwise or fail in clockwise position. Now, regardless of any of the functions, double acting or fail safe, it always has to be paired with a double acting positioner. Now, this actuator as it's currently set up can be easily piped into double acting. You'll just have to have one main air line, the supply air, go into the positioner, with two out ports from the positioner going into either port 2 or port 4 of the actuator. If you want to make this into a fail clockwise, all you would have to do is install our Namor trip valve, which we call the NTV, with the orientation pointing up. And if you want to make it fail counterclockwise, you just turn the NTV upside down and install it like this. We're going to start the demonstration with fail in clockwise position. So I'm going to install the NTV facing up. Now let's talk about the function of the NTV a little bit more in detail, and also let's talk about the piping between the NTV and the positioner. The function of the NTV is to drive the actuator to its fail-safe rotation only upon the loss of air supply. What you have over here is your main air supply line. Instead of being piped directly to the positioner, it's going to be first piped to this port on the NTV, and then the main air supply line will be then redirected to the supply line on the positioner itself. Since this is a double acting positioner, you would have two air lines connecting the NTV to the positioner. Because the NTV is currently set to close in the clockwise orientation, if you want the positioner to move the actuator to a clockwise orientation when there's a loss of signal only and you still have the full air supply, you would need to connect this port over here to the port that's blowing full air, like so. And you'll notice that there's no signal connected to the positioner. And then you will connect the remaining port to the opposite side. And this setup, when there's a loss of electrical signal, but no disruption in the air supply, it's still gonna rotate the actuator to the same clockwise closed position. Now you can reverse these two signals, and what would happen is when there's a loss of electrical signal but no loss of air supply, it will drive the actuator to the full counterclockwise rotation instead of a clockwise rotation, which will be inverse of what the NTV is set for on a loss of air supply. The NTV is set for fail in clockwise and will move counterclockwise on increasing signal. I'm increasing the signal. Loss of air supply. Resuming air supply. Loss of signal. Okay, now we're going to change the NTV into the fail and counterclockwise, as well as change all the piping associated with it. NTV is going to get turned upside down, bolted in place. Okay. Now you'll notice that the main air supply line is still going to be connected to the supply port on the NTV, which is going to get redirected to the supply port on the positioner. Okay. Now, if you want the positioner to drive the actuator into the same field counterclockwise when there's a loss of electrical signal only and you still have the full air supply, connect this port to the port that blows full air on loss of air supply, which is over here. It'll be connected to the far end over there, and the remaining port would then be connected to the opposite port on the positioner. If, however, you want to get very creative in your setup and you want the positioner to fail in a clockwise orientation only when there's a loss of electrical signal, which is going to be different than the fail in counterclockwise when there's loss of air supply, you'll connect this port to the port that has full air supply with no electrical signal, and connect this port to the other port. The NTV is set for fail in counterclockwise and will move counterclockwise on increasing signal. Increasing the signal. Back to 4 milliamps. Loss of electrical signal. Electrical signal back to normal. Loss of supply air. Supply air back to normal. Increasing the signal. Loss of supply air. Supply air back to normal. Loss of signal. One thing to keep in mind when you change the movement of the actuator from clockwise to counterclockwise or vice versa on increasing signal is just to run AutoCal on your positioner. And depending on the positioner manufacturer, you may need to change the action of the positioner from reverse acting to direct acting as an example. And some may require some cam changes to be made on the positioner.